Hello friends, welcome to video series on geography. In this video I'll be explaining about atmosphere, its importance, its composition and different layers of atmosphere. Let us first take a look at importance of atmosphere. Atmosphere is an envelope or blanket of gases surrounding the Earth's surface. They might extend up to few hundred to few thousand kilometers. In the initial stages when the Earth was born, there was very meager amount of atmosphere surrounding the Earth's surface. Due to intense volcanism and various other geomorphological processes, the atmosphere on the Earth's surface got thickened with the passage of time. And initially, the atmosphere was full with carbon dioxide and various other harmful gases. But due to evolution of various microorganisms, which in the initial stages observed anaerobic respiration, where their respiration was in the absence of oxygen, and these life forms converted into higher life forms like oxygen producing bacteria like blue-green algae bacteria, etc., where during their anaerobic respiration process they gave out oxygen, and slowly the oxygen levels in the atmosphere rose, and this process continued for a very long time, and the rising oxygen levels were conducive for the creation of higher life forms. And slowly, with this process, continuation of this process, the life forms on Earth got diverse, and we can see the the whole present life system on Earth is mainly due to presence of atmosphere. So, atmosphere is important in both creation as well as perpetuation of life on Earth. The next important feature is the absorption of harmful ultraviolet radiation by atmosphere. We know that there is a layer called ozone or O3 in stratosphere. We'll see what is stratosphere. And this ozone layer is very important because it absorbs harmful ultraviolet radiation which are emitted by sun. Ultraviolet radiations are low wavelength high frequency radiations which come before visible radiation in electromagnetic spectrum. We know that electromagnetic spectrum has gamma rays, X-rays, visible light, ultraviolet radiation, infrared, microwave radio waves, etc. Initially there are gamma and X-rays which are very low in wavelength, which are very small wavelengths, and after that it's ultraviolet radiation or UV rays. Ultraviolet radiations have wavelengths ranging from 1 nanometer to about 400 nanometers, and then it's visible light which has about 400 to 720 nanometers, and then it's infrared 720 to 1 millimeter, and then it's radio waves and microwaves. So from this electromagnetic spectrum we see that ultraviolet radiation has high frequency and low wavelength compared to visible radiation. So this is the radiation that we receive from sun, and this radiation is harmful because it might cause skin cancers, skin burns, and DNA mutations and various other unnecessary unwanted phenomena which are harmful for life forms on Earth. So it is important that to sustain life on Earth, this radiation is blocked, and this blocking is done by O3 or ozone molecules, and this layer is present in stratosphere of Earth's atmosphere. And the other important concept is called greenhouse effect. Greenhouse effect is an heat trapping effect where heat trapping gases like carbon dioxide, that is CO2, and ozone, O3, methane, CH4, and mostly water vapor. All these are important heat trapping gases which are present in atmosphere, and most of these gases are present mainly in the bottom layers of atmosphere like in troposphere and stratosphere, and these layers are very important in maintaining the constant temperatures on Earth. We know that Earth receives sunlight in differential amounts. For example, the lower latitudes, that is the latitudes surrounding the equator, which are called tropics, receives high amount of sun's rays, whereas the higher latitudes present in temperate and polar regions receives low amount of temperature. So if this is Earth, the regions surrounding the equator like tropics are energy surplus regions, that is they gain more heat sun's energy than it is lost, whereas the upper regions, mainly temperate and polar regions, all these parts both on south and northern hemispheres, are energy deficit regions because here more amount of heat is lost then heat is gained. So by this principle, we can assume that polars polar regions would be much more colder than they are today. For example, now on an average, polar regions would have a temperature surrounding from 0 degrees Celsius to minus 40 to 50 degrees Celsius. But if there was no atmosphere, this temperature would have gone to minus 500 or 600 degrees Celsius. And at the equator, near the equator in the tropical regions, the temperature would have been around some few hundred degrees Celsius, which would be very hot, and there would be no life on Earth's surface. But these are the gases that make the existence of life possible by maintaining constant levels of temperatures on Earth. For example, the heat surplus region like the equators and tropics, the heat received here is absorbed by these gases, important heat absorbing gases, and this heat is transferred by various movements of winds. That is, these gases move in the form of winds, and this wind is transported from one location to other location. As a result, the temperatures or heat is also transported. Likewise, in polar regions too, the heat deficit region, the required amount of heat supplied from the equatorial region. As a result, there is a heat balance between polar and equatorial regions, where the extreme levels of heat in the equatorial regions is balanced by reception of heat in the polar regions, where the heat is low, that is, they are energy deficit regions. So by this balancing effect, we see that temperatures on Earth remains fairly comparative. That is, the temperatures at tropical regions would be around 50 to 45 degrees Celsius, whereas at the poles it would be about minus 50 to minus 70, 80 degrees Celsius. And the lowest recorded temperature is in the Antarctic. It is about minus 82 degrees Celsius. And this thing has changed recently. It was much higher, I guess. But these kind of extreme temperatures are balanced by mostly these gases called as greenhouse gases, and the effect is called as greenhouse effect. So greenhouse effect is very important in maintaining constant or least temperature variations on the Earth's surface. Thus, it is a great phenomenon which influences the creation as well as perpetuation of life. And the next important one is that the atmosphere doesn't allow extraterrestrial objects like meteors to hit the Earth. In most of the cases, meteors which enter the Earth's atmosphere get burnt in the mesosphere. As a result, most of them don't hit the Earth's surface. If these substances hit the Earth's surface, then it would be catastrophic on the Earth's surface, as it would lead to volcanism, earthquakes, tsunamis, and various other natural calamities. So what are meteors? Meteors are parts of asteroid belt. Asteroid belt is a belt which revolve around the Earth between orbits of Mars and Jupiter. This asteroid belt contains small rocks whose radius varies from few meters to few kilometers. And these rocks sometimes escape from this asteroid belt and move towards Earth. When they are attracted by Earth's gravitational pull, they come very close to Earth and sometimes even enter the Earth's atmosphere. As atmosphere gets thicker as we come closer to the Earth, these rocks, enough friction is created for these rocks to burn up completely in the mesosphere. Sometimes when meteors are bigger in size and they are very denser, then certain parts of meteors might remain unburnt and hit the Earth's surface, giving rise to craters like we can see these craters. These craters are present on Moon. As Moon has no atmosphere, the Moon's surface is filled with these kind of impact craters where different meteors have hit the surface since few million years and before that too. So if Earth had no atmosphere, then even Earth's surface would be like the surface of the Moon, where it has many impact craters, and this kind of impact craters is not conducive for existence and as well as perpetuation of life forms, as due to various calamities there would be mass extinctions and there would be complete wipeout of life on Earth. But as we have atmosphere, these kind of impact craters are very few in number, that is, they rarely occur on Earth's surface, hence saving the Earth's surface from this meteor impact. The atmosphere plays an important role in keeping daytime and nighttime temperatures fairly in close ranges. That is, diurnal temperature variation is very low, hence it doesn't turn adverse for the life forms on Earth. If there was no atmosphere, the daytime temperatures would be much higher and the nighttime temperatures would be falling by a few hundred degrees Celsius. Hence, the temperature range would be around, change in temperature would be around few hundred degrees Celsius, and this kind of change in temperature is not conducive for existence of life forms on Earth. As a result, the atmosphere also plays an important role in keeping the daytime and nighttime temperatures fairly in closed ranges, and this is mainly due to happens due to greenhouse effect, that is due to heat trapping gases like carbon dioxide, methane, etc. And also there are other phenomena like ocean currents, wind systems, etc., which also help in maintaining the heat balance on the Earth's surface as well as heat balance during days and night times. So atmosphere is very important for both existence as well as continuation of life on Earth. And the table here indicates the composition of atmosphere. Atmosphere is made up of important gases such as nitrogen, oxygen, and carbon dioxide. Other gases like argon, neon, krypton, and xenon are called as noble gases, which are least reactive in nature. And hydrogen and helium are lighter gases which are present mainly in the outer layers of atmosphere. And of all these, nitrogen, oxygen, and carbon dioxide are very important because carbon dioxide helps in greenhouse effect, oxygen supports life forms on Earth, and nitrogen is important in stabilizing oxygen. Oxygen is highly inflammable gas. As a result, if atmosphere is filled with oxygen, it would simply be a burning envelope of gases. As there is abundant amount of nitrogen, it stabilizes oxygen and doesn't let oxygen burn in normal conditions. And nitrogen is a very important nutrient for plants. As a result, it is very important in sustaining plant life forms. And by volume, nitrogen makes the highest amount of gas. It is about 78% of the Earth's atmospheric volume. And oxygen makes up to 21% of the Earth's atmospheric volume. And the next one is argon with about 1% of atmospheric volume. And carbon dioxide is only about 0.03%. So the carbon dioxide levels is very low, and this low levels of carbon dioxide is able to keep the temperature balance on Earth. As a result, even a small variation in carbon dioxide levels lead to catastrophic climate changes. So the carbon dioxide changes are very sensitive, and even a small change can bring huge losses on the Earth's surface. And other gases like neon, which are noble gases, have least effect on Earth's atmosphere. Helium and hydrogen are present on the outer surfaces, and they are very low in volume. And there are other trace gases which are negligible in volume. Water vapor is another very important component of atmosphere. It helps in both greenhouse effect as well as hydrological cycle. And the water holding capacity of air increases with increasing temperature. As a result, in tropics where the temperature of air is high, the volume of water is high, whereas at poles where the volume of the air is cold, the water holding capacity is low. As a result, it is only about 0.2% of water vapor present near poles. And most of the water vapor content is present at the bottom layers of the atmosphere. At higher layers, it is negligible, and within 6 kilometers, there is about 90% of the moisture in the form of clouds and other forms. And above this, the water vapor content is highly negligible. And we have seen it exhibits greenhouse effect, which further helps in maintaining heat balance on Earth's surface. Thus, water vapor is an important greenhouse gas. The most important property is that water vapor can absorb both the radiations which come from sun as well as the radiations which are emitted by Earth. The sun emits radiation in the form of short wavelength radiation like ultraviolet rays, and these rays can be absorbed by water vapor. And also, after Earth receives this ultraviolet radiation and converts this into infrared radiation or the heat, even this heat or infrared radiation can also be absorbed by water vapor. As a result, water vapor turns out to be very important component of atmosphere when it comes to greenhouse effect, as it can absorb both ultraviolet radiation, which is a short wavelength radiation, as well as long wavelength radiation or the infrared radiation. And also, water vapor results in various phenomena like scattering, dispersion, and even rainbows, etc. We'll deal about these things like scattering, which various other properties of light and atmosphere when we deal topics related to general science. Water vapor is an important source of precipitation and clouds. Hence, it helps in maintaining hydrological cycle in the atmosphere, thus balancing the amount of water present in both oceans as well as on the continents. And the most important of all is it supplies heat to storms in the form of latent heat of condensation. That is, let's see this in detail. This graph shows energy supplied to a system and consequent rise in temperature of the system. Let us take a solid substance where energy is supplied to this solid substance, and when energy is supplied, then the temperature increases. At a certain point of time during this stage, though the energy is supplied, there is no increase in temperature. Instead, the amount of energy supplied is used for change of state of matter. For example, this energy is utilized to convert this solid substance into a liquid substance, and this amount of energy which is consumed in converting the state of a substance is called as latent heat of fusion. That is, when it is used to convert solid to liquid, it is called as latent heat of fusion. And this amount of temperature, that is energy from here to here, is latent heat of fusion. And likewise, to convert a liquid into gas, we need to supply certain amount of heat. During this supply of heat, there is no increase in temperature of the system, whereas the amount of heat supplied is used for changing the state of matter, that is from liquid state to gaseous state, and this is called as latent heat of vaporization. During this state, that is when this kind of heat is supplied, there is no increase in temperature of the system, whereas all the heat supplied is used for changing state of matter. When the reverse process happens, that is when gas gets condensed into a liquid, this is when gas gets condensed into a liquid, the same amount of energy is released into atmosphere, and this energy is called as latent heat of condensation. So this energy which is supplied by latent heat of condensation is the driving force behind all storms and other cyclonic features. And water vapor along with dust aerosols gives rise to various phenomena like scattering, reflection, refraction, dispersion, etc. We'll see all these things in detail when we deal topics related to general science. For now, you just remember that aerosols absorb water vapor, hence aerosols help in condensation of water vapor, and in the condensation process, when the size of the water vapor is considerably large so that it allows phenomena like scattering, reflection, refraction, and dispersion. So various phenomena like the red color of the sun at the dawn and dusk, as well as the blue color of the sky, blue color of ocean, and rainbow, etc. are all mainly because of water vapor and other atmospheric layers. So we'll study that in detail later. Now let us take a look at different layers of atmosphere. Atmosphere is mainly divided into 5 important layers, namely troposphere, which is the bottommost layer which is surrounding the Earth's surface, followed by stratosphere, then mesosphere, thermosphere, and the outermost layer is called as exosphere. The layer's exosphere coincides with the boundary of outer space. It is hard to distinguish between boundary and the atmosphere, and density decreases with increase in height. That is, as height increases, the density of atmosphere decreases. As a result, the troposphere is the most densest layer, whereas the exosphere is the least densest layer. Let's see all these layers in detail. The first important layer is troposphere. It is the bottommost layer that covers the Earth's surface. It extends for about an average about 13 kilometers above Earth's surface. That is, its average thickness is about 13 kilometers. At the poles, its average height is only about 8 kilometers, whereas at the equator, its average height is about 18 to 17 kilometers. This change in thickness at poles and equator is mainly due to differential amount of heat received by various latitudes. For example, equator receives highest amount of heat. As a result, the air at the equator is vaporized and increased in volume, and as temperature of this air increases, it rises above. Hence, there is thickness of troposphere at equator, whereas at poles, as the air is very cold, the air condenses and doesn't. There is no increase in volume, or the air doesn't rise towards the upper layers. As a result, there is no increase in thickness of troposphere. As a result, thickness here is least. It is only about 8 to 9 kilometers. And the most important feature in this layer is that temperature falls with increase in height. This is called as lapse rate. On an average, the lapse rate is about 6.5 degrees Celsius per every kilometer. That is about 1 degree Celsius for every 165 meters. That is, as we move upwards, there is 1 degree Celsius decrease in temperature with a distance of 165 meters. And we can see how the temperature decreases. That is, at the very bottom, it's about, on an average, it's about 25 to 27 degrees Celsius. But when it reaches the maximum height, then the temperature would be only about minus 50 degrees Celsius. And this varies at poles as well as equator. That is, at poles, the average temperature at the maximum height is minus 45 degrees Celsius, whereas at the equator it is about minus 80 degrees Celsius. This is because of varying thickness of troposphere at equator and poles. We know that at equator the thickness is about 18 kilometers. Hence, the fall in temperature is higher as there is huge distance between Earth's surface and the upper layers of troposphere. Whereas at the poles it is only about 8 kilometers. As a result, lapse rate is low as the distance is smaller. And this is the meteorologically very important layer, as most of the weather phenomena like precipitation, clouds, wind systems, pressure systems, etc. happen in this layer. And beyond this layer, all these features becomes less significant. All convection stops here. That is, all the rainfall activity due to convection cycle stops here. We know that due to differential heat, there is movement of particles of atmosphere from highest temperature layer to lowest temperature layer, where the heat is supplied to the upper layers, and then once the heat is lost by these air, then this air cools and falls down to the bottom, and this cycle repeats, which is called as convection. And this stops in troposphere. It doesn't extend beyond troposphere. And about 80% of the mass of Earth's atmosphere is in troposphere. This is because of greater density at troposphere. We know that all the upper layers, namely which are all above the troposphere, are very less thicker. That is, they are least in density, whereas the troposphere has maximum density, and it consists of about 80% of the mass of total atmosphere. And troposphere has mainly heavy elements like heavy gases like hydrogen, oxygen, carbon dioxide, water vapor, etc. And the majority of the volume is consumed by nitrogen, which is about 78%, and the oxygen is about 21%. So these gases are negligible in other layers, as they are heavy. They flow only on the outer surfaces of the or the bottom layers of the atmosphere. When we move further, mostly hydrogen and helium become dominant as they are lighter gases. But at the lower layers, it's nitrogen, oxygen, carbon dioxide, water vapor, etc. which are dominant. And all the moisture is found in troposphere, as we have seen, because of decrease in, as most of the convection cycle and various other weather related phenomena happens in troposphere. The amount of water vapor is also maximum in troposphere. Almost it is negligible in other layers. And the outermost layer of troposphere is called as tropopause, which separates stratosphere and troposphere. This small layer where temperature remains constant is called as tropopause. Here the temperature remains constant, that is, at the bottom, at the upper layers of troposphere, there is cease in lapse rate, and beyond that, for about 5 to 6 kilometers, that is near at the layers of tropopause, the temperature, there is no change in temperature, and the temperature remains fairly constant through all these distances till it reaches the stratosphere. And the next important layer is stratosphere. This layer is marked by increase in temperature. It extends from about 13 to 50 kilometers, and here the density is so low that the pressure would be only about 1,000 to the pressure compared to at sea levels. That is how low the density is. And temperature rises with altitude mainly because of the presence of chemosphere. Chemosphere is also called as ozone layer, that is O3 molecule, combination of O3 molecules. This layer is very important as it absorbs most of the ultraviolet radiation that reaches the Earth's atmosphere. And ultraviolet radiation is dangerous for terrestrial life, as this light can induce mutations, genetic mutations, skin burns, skin cancers, and various related diseases. As a result, absorption of this light by ozone is a very important phenomenon. And this layer is mostly free of clouds and various other weather phenomena. Only few types of clouds, which are mostly gaseous filled with gases, are found at the bottom layers of stratosphere. There is least amount of or negligible amount of water vapor in stratosphere. The next layer is mesosphere. This layer extends from 50 to about 80 to 85 to 90 kilometers. And this is the coldest layer on Earth as well as coldest part on Earth. Its average temperature is about minus 85 degrees Celsius. At the poles, at the least, the temperature recorded is about minus 82 to minus 90 degrees Celsius, that is in Antarctic region. And this very region called mesosphere has an average lower temperatures of about minus 85 degrees Celsius. That is how temperatures could go, and it could reach much lower, like minus 100, minus 120 degrees Celsius. Hence, it is the least hottest place of Earth. Even atmosphere is a part of Earth as it is influenced by Earth's gravity. As a result, we consider atmosphere to be a part of Earth. Hence, this layer becomes the least hottest layer of Earth. And most of the materials burn up in this layer. This is a very important feature because materials burning up in this feature is essential to keep the Earth's surface safe. If this kind of atmosphere wasn't present, then the Earth's surface would be bombarded with various asteroids, that is remnants of asteroid belt or meteors, and it would lead to impact craters, which would further give rise to volcanism, earthquake, tsunamis, etc. As we have atmosphere around the Earth, there is no risk of meteors hitting the Earth. Most of the meteors gets burnt in this mesosphere, and few densest and biggest meteors might pass these layers and enter the inner atmosphere and sometimes even hit the Earth's surface. But there are only few such impacts, very negligible amount of impacts. And the next important layer is called as thermosphere. Thermosphere is marked by increase in temperature. It extends from about 85 to about 500 kilometers above the Earth's surface. And this layer is electrically charged layer because of ionization of layer. Ionization is a process in which the outermost electrons are peeled from the outermost shells of an atom. As a result, there is a charge induced to an atom. This is called as ionization. And during this ionization, there is huge amount of heat released, which gives rise to increase in temperatures of thermosphere. This is the most important part in radio communication, as most of the radio wave communication is carried on based on this layer. That is, when a receiver transmits an radio wave radiation at a certain angle, it gets reflected by thermosphere and it is transmitted back to the surface of the Earth, where a receiver receives this radio wave signal. Hence, it is helpful in radio wave communication. In case if the signal has to be transmitted to the outer surface, then radio waves would be sent perpendicular to the layer where the reflection would be zero, and the ray would pass outside the thermosphere, which would be reaching a satellite or an international space station or any communication device. But for transmission, we transmit at certain angles so that there is no escape of the radio wave, and it gets reflected and is received by a receiver. Hence, this layer is most important in radio wave communication. In this layer, temperature starts decreasing. This is the most important phenomena. The decreasing temperature is mainly associated with ionization of atoms. Increasing temperature is mainly associated with ionization of atoms. And though there is huge increase in temperatures, where temperatures would rise to few hundreds to few thousand degrees Celsius, a person in this layer will not feel a significant amount of heat, because the density of this layer is so low that the atoms present in this layer are separated by few hundred kilometers. As which is why a person would not feel any heat in this region. This region is important for placing various satellites and various other celestial man-made objects like International Space Station, various communication and defense satellites, etc. Though higher temperatures would not be conducive for placing these satellites, but as due to very low density and separation of atoms by hundreds of kilometers, there is significantly no heat felt. As a result, this remains a safe place for both International Space Station as well as satellites. And the outermost layer is called as exosphere, and the layer that separates thermosphere and exosphere is called as exobase. This is a very thin layer whose properties are mostly similar to both thermosphere and exosphere. Exosphere mostly has hydrogen and helium as its major constituents. As hydrogen and helium are lightweight gases, they would escape higher towards the exosphere and would settle in exosphere. And it extends from about 500 kilometers to about a few thousand kilometers above the Earth's surface. And this layer extends from about 500 kilometers to about several thousand kilometers. And the density is very negligible. There are few atoms scattered here and there in the layer, and the distance between atoms can be few hundreds to thousand kilometers. That is how least dense it is, and it is composed of extremely low density atoms like hydrogen and helium, as said earlier. In this layer, temperature gradually increases. This is mainly due to exposure of this layer to the intense sunlight, as there is no other obstructing substances in between sun's and exosphere. The temperature or heat received from sun is so high that the temperature gradually increases to few thousand degrees Celsius above the Earth's exosphere. And auroras are one important phenomena which are observed in mostly outer layers of thermosphere and mostly in exospheres. We have talked about auroras while dealing magnetosphere and magnetopause. We have talked about how Earth's magnetic layer helps us in driving out the solar wind, so that Earth's atmosphere as well as Earth's interior, Earth's surface remains safe. So auroras are a phenomenon where charged particles or ions reach the Earth's surface through these magnetic lines. We know that Earth has a magnetic field. This is how it runs, North Pole to South Pole, north to south, and these magnetic lines bypass the solar wind, other charged particles. So these auroras or simple light phenomena are observed near poles. These are very important weather phenomena. And this is the temperature and sound profile of atmosphere. One important feature is that the speed of sound follows the profile of temperature. We can see it mainly follows the temperature, the sound profile of temperature. They are almost similar in shape. This is because the velocity of sound depends on temperature. We usually think that velocity of sound depends on density. This only applies when the sound is traveling on the surface of Earth or within solids, liquids and gases. But in atmosphere, this feature is different. As density decreases from bottom to top, we think that the velocity would also decrease from bottom to top. But in reality, the speed of sound would follow that of the profile of temperature. This is because the speed of sound is directly proportional to temperature. And coming to significance of various layers, we see that most of the aeroplanes and other man-made objects fly almost at the outer layers of troposphere in tropopause and at the bottom layers of stratosphere. Stratosphere is important in absorbing ultraviolet radiations. Stratosphere has ozone layer which extends from about 25 to 45 kilometers, and this layer is the main reason behind absorption of ultraviolet radiations in stratosphere. And meteors burn up in mesosphere, and most of satellites are placed in thermosphere and exosphere. The International Space Station is in thermosphere. Auroras are observed in both thermosphere as well as exosphere. And this is the end of the video. Thanks for watching.